Okay, well, we're about a minute in, so we'll go ahead and start the discussion. Looks like there's about 80 people on the line right now. So if you're looking for the commissioning on sky observing strategy, you're in the right place. So Chuck is the chair of this session, and then I'll be walking through this presentation. So I'm Keith Bechtol. I am the commissioning science verification and validation lead for the project. So let's go ahead and remind everyone of the friendly reminders for the code of conduct. Let's make this a nice, respectful session, and I'll assume that we're coming into this with positive intent and we're working together. That's certainly the spirit that we're trying to engage. And then we'll go ahead to the session format and logistics. For this session, we'll be asking people to post their questions in the Slack channel. That's the preferred, so that's linked here. We will also be monitoring Zoom for questions. If you use the raise hand, you can ask a question verbally. So if someone could help monitor the Zoom raise hand and Slack for questions, that would be appreciated.
I can do that for you, Keith.
Thank you. And Eric Dennehy will be our scribe. For those of you who don't know Eric, he's recently joined the team as one of the science verification scientists on project. There's also a shared Google Doc that's editable by everyone that you can take minutes and make any corrections if needed. So for this session, please feel free to ask questions during the presentation itself. If it's more interactive, that could be beneficial. There'll also be some time at the end for questions, but feel free to stop as we're going. Okay, so here are the topics for today. We'll begin with a review of the commissioning timeline and some of the current planning for the on-sky observations to give a sense for what this current state is. Then we'll go into a summary of reviewing the community input that we received last year via the commissioning notes. And then we'll close up the session with a roadmap to the detailed on-sky observing strategy during commissioning, and basically ways for the community to continue providing input on this. I should mention that there's a related session on early science that's actually in the next parallel block. So there'll be more information specifically about accessing the data previews at that time. So first off, to begin the session, Chuck and I would like to express our deep thanks and gratitude for all the groups that provided input and that submitted commissioning notes in response to the call for input in 2020. This was exactly the kind of input that we were hoping for at this stage of the process. We've read all of these notes and really value all of all the thought that you put into this, especially recognizing that the past year was not an easy year to take on this task. So thank you very much for that input, and we will continue to move forward with that as we'll describe in the rest of this session. So first, we want to just set some expectations for how this community input would be used. In general, the data content from the commissioning period is a shared risk or best effort situation, where from the project standpoint, we need to prioritize the technical and scientific verification of the formal system requirements so that we can demonstrate construction completeness and readiness for operations. But within those boundaries, we would like to try to make the observations as useful as possible to the scientific community, so that we're basically looking at this as an opportunity. The detailed schedule for on-sky commissioning observations is still to be determined. There is some flexibility in the exact design. And as mentioned before, from the commissioning team standpoint, we would like to try to acquire data during the commissioning period that would enable a wide variety of science validation studies. And so any kind of community input is very welcome and appreciated to help us do that design in a way that's beneficial for science validation. But in contrast, we want to draw a contrast between the commissioning observations and a normal TAC process. Basically, we cannot ensure that any particular observations will be taken during commissioning. It will ultimately need to be driven by the needs of the project to demonstrate operational readiness.
Keith, can I interject here real quick on this topic?
Please.
Yeah. Just to put another point on what Keith just summarized, that the purpose of these community inputs is that to a large extent, the technical observations that we have to do are more or less agnostic about what place on the sky we observe. And so part of this ask from the community is that if we had to pick a spot on the sky to observe, to do some technical observation or technical measurement, where would be a scientifically interesting place to look? And what kind of parameters for those observations would be interesting to you? So, sorry, Keith, back to you.
Yeah, thanks for adding that, Chuck. Okay, so looking at the key dates, because this is partly driving when we have requested input and how we'll continue to use input in the future. So right now we're at the stage where in the current schedule, ComCam would be going on Sky in roughly January of 2023. So a little bit more than a year and a half from now. LSST-CAM would be going on Sky in July 2023. And the science verification survey start would be in October 2023, with the earliest construction completeness date being in January of 2024. So these are the early completion dates. There's a schedule contingency estimated at about 6 months. And so the dates above would move later in time if that contingency was used. In the current schedule, there are 2 months that are planned for sustained on-sky observations with LSST-CAM. And this is specifically intended to be used for science verification and validation. And this is what we are referring to as the SV survey, is this more contiguous block of observing that comes at the very end of the construction period. So right now, this would nominally be late 2023. So with regards to the process of community input, we began last year making this a bit more formal with this phase 1 of community input. So we made a post on LSST community that was welcoming input from the science collaborations in the form of brief commissioning notes. We held a session at last year's PCW where we included presentations from representatives of the science collaboration. So we had six very informative presentations last year. There's a commissioning liaison Slack channel in the LSST workspace where we had more discussion. And then Chuck and I participated in workshops with individual science collaborations as requested. So we participated in a few of those to help, basically help the science collaborations, learn about the process and how the information would be used. And then there's a publicly accessible Google Drive that contains the commissioning notes that were submitted last year. So far, we have received notes from 5 science collaborations, and these are spanning the 4 main science drivers of LSST. So we were quite happy with the feedback we've received so far. So now we're in phase 2 of this process of community input. This is the stage at which the project will produce a menu of candidate target fields, and we'll use the input received so far as in that process of producing the menu. We will share that with the community, and then we'll be iterating with the community as we get closer to the time of first light. So right now, we're sort of taking a little bit of a break until the schedule becomes more certain as we get closer to on sky. And then we'll be basically taking that input, making the menu of fields, and then mapping the needed observing programs for commissioning to these particular targets. And that will happen closer to the time of first flight. So here's a sort of a more graphical view of what we've been talking about so far in terms of looking at the schedule. This is the same chart that Chuck showed in the commissioning update session earlier this week. So there's these three main phases of commissioning in terms of the on-sky observing. First is the early system integration and test with ComCam. So this is 3 months that's mainly focused on engineering activities, but could include some opportunistic science-like observations. There will be a similar period that's more engineering focused with LSST-CAM as that's being installed. And then the third phase, which is in these green boxes, would be the science verification surveys. And so as a reminder, data preview 1 would be including data from the ComCam commissioning period. And then data preview 2 would include data taken during the technical integration phase of LSST-CAM, as well as the science verification surveys. So this next slide here is intended to give some sense for the data that would be collected during commissioning and sort of a baseline plan that we've developed so far. So during the ComCam and LSST-CAM integration and test periods, again, these are several months, basically right when the cameras are being installed on the telescope that are more engineering focused. But we do anticipate getting modest amounts of science quality imaging. This could be ranging from a few hours to a few nights, maybe more if we're lucky. Generally, these are expected to be small areas of sky sampled with a high temporal density, because we would need to take the observations in a way that they could be used immediately for engineering purposes and for that initial science verification. So in general, it's probably not going to look too much like the normal LSST wide fast deep sampling. A possible exception to that might be periods where we are testing the scheduler. And so this might be operating the scheduler in a mode that looks like the wide fast deep survey for LSST to demonstrate that we can basically operate in that mode, but it would be sparsely sampled because we wouldn't be conducting a coherent survey. It would be mainly for the purpose of testing the scheduler. So where things get a bit more structured is when we get to the science verification surveys with LSST-CAM. And so under this second bullet here on this slide, this is what we've been calling an example minimal plan. So this is intended to show a set of observations that we believe would be sufficient for doing the minimal level of science verification to demonstrate operational readiness. So this would include, for example, observations that could be used to test single visit performance. So for example, taking observations that look like star flats. This would be testing astrometric, photometric repeatability for the calibration. There could be scheduler testing for the nominal scheduler, or if there was, if we wanted to test TOO capability, for example. We may want to have at least some time set aside for observations of challenging regions. For example, very bright stars or very crowded regions of the sky, astrophysically speaking. And then we would like to devote significant amounts of time to surveys. And so our current baseline concept would include a full depth survey where we would take at least one external reference field and go to a deeper integrated exposure than the normal 10-year wide fast deep, perhaps 20-year depth. We would do this in all bands, and part of the purpose of this is to test different dithering strategies, and so we'd want to include some extra allowance for that. So a nominal plan would be that this would take something like 8 nights. In addition to that full depth survey, we've been talking about doing a wide area survey where we would cover For example, 800 square degrees and multiple filters to a 1-year depth. We would do a first pass to build templates, and then we would come back at a later time, repeat these observations, and basically attempt to do the full process of alert generation using the templates from the first pass. So that wide area survey, as written here, would take something like 20 nights. So this is a sense of what a minimal observing program might look like. I think it's useful to also show a variation. So this variant, you might call this sort of a consolidated concept. Given that we have quite a short period for the on-sky sustained observations during commissioning, one could imagine trying to consolidate the observations into a single, more coherent survey program. If you were to concentrate all the observations in this way, just to give a sense of what would be possible, you could take 100 square degrees in all 6 filters to a 20-year equivalent depth in about 30 nights. So again, this is presented as a contrast, another approach that could be taken. So part of our thought process right now in terms of general considerations is that through the commissioning notes received last year, there are many well-motivated concepts for both scientific and technical investigations that could be done during commissioning data. If we were to try to pursue all of these concepts, it would take significantly more time than what we actually have during the on-sky science verification survey period during commissioning. And so given that we have limited available time, there is some consideration of the relative value or balance between trying to accomplish as many of these different programs as possible, basically having a broad mix of targets. This would likely result in more widely distributed and smaller area fields, probably more heterogeneous in terms of the depth and the band coverage. The advantage of this type of approach is that it potentially increases the total number of external reference fields and astrophysical targets of interest that could be observed during the commissioning period. So that would be balanced against having a more coherent survey, where there would likely be a smaller number of contiguous fields. These would be more uniform in their depth and band coverage, and potentially have a broader sampling of different temporal cadences. So both longer baselines and shorter time baselines. So one way to think about this is that during the assembly integration and test phases with CONCAM and LSS-TCAM, there will be these opportunities for more targeted sort of snapshot-like observations where we might hit sort of a mix of targets, just depending on what's available on a given night. But then we could transition to something more structured during the SV surveys. And in some ways, the baseline plan that we've developed is somewhat of a compromise between the two. But Chuck and I wanted to present these different options to the community just to give a sense of what we're thinking about, because there could be a high value in thinking about a more structured, unified observing survey that might have higher legacy value than trying to attempt as many of these as possible. Maybe it's worth taking a pause here to see if there's any questions.
Keith, this is Amy. We do have one question in the chat. Mario is asking why 20 years?
We've typically talked about wanting to achieve at least 20-year equivalent exposure during the commissioning period, because we intentionally want to oversample, both in terms of the increasing the signal to noise that we can get in a particular region of the sky. We want to be able to detect fainter objects and have higher signal to noise so that we can use that as a calibration for the performance of the wide area survey. Another reason that we want to do this is we want to stress test the science pipelines with that type of data that's going to have even more blending and potentially expose systematic effects that we would want to investigate early so that we can adapt the science pipelines as needed. We want to have that awareness as quickly as possible. And then a third reason is that if we observe the same region of sky at greater depth, basically more total exposures, we can slice that data set in different ways when building coads to explore changes in performance with respect to telemetry, observing conditions, et cetera. I know Robert Lupton has been a big advocate of this high depth strategy. So I don't know, Robert, if you want to add anything.
Well, you can just slice the data lots and lots of different ways. I mean, you can say, get statistical errors on your measurements by taking the same data and process independent data sets in different ways, as well as things like the best seeing or the worst seeing, every other. So basically it gives you the full exploration of the 10-year depth without bootstrapping it, essentially. It also gives you, and everything else Keith said, you want to know what's going to happen to the DDFs? Here's the place to look for the deep drilling fields. Does that help, Mario?
Yeah, definitely. Thanks.
Any other questions at this time? The next topic will be a review of the input received to date. Okay, then let's go ahead and keep going. Okay, so the next set of slides is giving a summary of the individual commissioning notes. So we'll basically step through the feedback that we've received, and then we'll make some more general observations or general trends about the input received so far. Several of the commissioning notes were quite lengthy and detailed, and we appreciate all that information. So for the purpose of this summary, we'll just focus on the highest priority observations that were suggested. But I would definitely suggest that people who are interested in this topic to read the commissioning notes. They're all publicly available, and you can see the full range of suggestions that were made. So let's start out with the Solar System Science Collaboration. So in their commissioning note, the Solar System Science Collaboration, they organized their suggestions into those directly related to the wide, fast, deep survey of LSST, and then those observations that might be useful for other more specific observing programs or not necessarily directly connected to the wide, fast, deep. So one of the first highest priority topics that was mentioned was validation of incremental template generation. This is the concept that during the first year of LSST, there will not be templates available over the full sky. And so there's a lot of interest in understanding how many observations are needed and what data quality is needed to build templates that you can begin doing difference imaging in a robust way. And can you actually begin that process as early as possible in the survey? Other topics that they're interested in are linkages of moving objects, and in particular, taking observations in different bands. They're interested in doing a bright comet stress test. This is an example of where we might not know the exact target until closer to the time of on-sky observations, just based on what is available. They're very interested in observations of basically known established fields where many solar system objects are known. So basically validating the solar system processing performance by looking at some of these reference fields that have been observed. And then in addition to the bright comets, they're also very interested in looking at a mixture of comets with different properties in terms of how quickly they're moving, their brightness, the degree to which they're extended, basically the activity level of the comet. In terms of the non-wide, fast, deep observations, Solar System Science Collaboration expressed interest in doing twilight observations, and in particular, looking sort of in the direction of the sun. So this could potentially catch near Earth objects, as well as near sun comets. And they're interested in understanding the performance of the camera during this twilight period, basically thinking about it as an opportunity to do a pilot of twilight surveys that could be undertaken during the 10-year LSST science operations period. For the transient and variable stars and stars Milky Way local volume, these two science collaborations teamed up to write a single commissioning note. Several of the concepts that were explored in their commissioning note had to do with specific science targets, and those are enumerated in this final bullet point here. But sort of their more general themes were that they were interested in conducting a short exposure survey during this commissioning period, both because they want to increase the dynamic range and because they're interested in testing the photometric calibration by having more overlap with Gaia, for example. Both these collaborations are interested in the performance of deblending and crowded field photometry. And this is one of the reasons why some of their unique commissioning science cases include some regions that have very high stellar density. The third bullet point here is the template observation for classification algorithm. What's meant here is that they would request observations at a high temporal sampling so that you would have reference light curves for astronomical objects in the actual LSST band passes, again, sampled at a very high temporal cadence. So you could use that as a reference when doing classification in the wide survey, which would have likely a sparser temporal cadence. They are interested in removing the saturation signatures of very bright stars. So in some ways, this is similar to what the Solar System Science Collaboration expressed in terms of their studies of, for example, bright planets or using bright comets. The transients in variable stars and stars Milky Way local volume also expressed interest in the deep drilling fields, in part because these will be fields that are visited with a higher cadence during LSST. So they would like to observe those fields. And they'd like to achieve, if possible, some overlap with the DES footprint. And again, they selected a large number of potential targets and a wide variety of different source classes, and those are listed in this last bullet point here. Okay, so let's go on to the Galaxies Science Collaboration. So some of their highest priority investigations include studies of low surface brightness features. So this included both in resolved stars as well as diffuse light. They're interested in the full depth galaxy photometry, so they definitely want to achieve 10-year depth or deeper in at least some of the commissioning fields. They're very interested in photometric redshifts and in testing SED fitting procedures that go beyond the photometric redshifts. And they're very interested in examining scattered light in galactic cirrus, including on the full field of view, in order to understand how that will affect galaxy photometry. So some of the specific recommendations in this commissioning note, they sort of group these into three categories. One is that they would like to target a nearby galaxy, where this means specifically galaxies within a few megaparsecs of the Milky Way. So they listed Cen-A, NGC 253, and M83 as candidates. These would be useful both for low surface brightness feature extraction, but also star galaxy separation, because in many cases, these have deep space-based imaging that can be used as a reference. And for these galaxies, they're close enough that at least some of the light is resolved into individual stars. And so they're very interested in it from that standpoint. The next area that they wanted to recommend was observations of wide fields. So they suggested SDSS Stripe 82 and Gamma/Kids as two candidate regions of the sky. Stripe 82 is particularly valuable because it's a useful reference for studying low surface brightness features. And then Gamma/Kids is valuable for its spectroscopic coverage. And then their third recommendation was the deep fields. So they particularly suggested Cosmos. And then in addition to that, CDFS or XMM/LSS. So these would be used for calibrating photometric redshifts, comparison to spectroscopy, and these have abundant space-based imaging that can be used as reference. In general, the Galaxies collaboration would like these fields to be observed with at least 5-band filter coverage if possible, again, because this is so useful for photometric redshift and SED fitting. So then we come to the desk, interested in cosmology. So there were 5 highest level recommendations from the desk. These were to observe an LSST deep drilling field to at least the 10-year equivalent depth for the Wide Fast Deep survey in multiple bands. So these are useful both for transient science for the type 1a supernova, as well as for calibrating photometric redshifts, for example. So again, one of the motivations here is to have the templates for doing supernova science and classifying other types of transients as well. Again, the deep drilling fields are the highest priority, and then you would try to expand coverage as possible. Their next recommendation was to observe contiguous wide field areas in equatorial regions. So we see again another reference to SDSS Stripe 82 as a potential target. And then they would also like to observe fields that have overlap with high resolution space-based imaging. Again, this is similar to what was requested by the Galaxies science collaboration. This would be useful for studies of object detection and deblending, galaxy shape measurement, and star-galaxy separation. And then finally, they have a recommendation related to photometric calibration that they would like to alternate imaging of the deep drilling fields with spectrophotometric standards in order to help tie the absolute calibration and crossband photometric calibration. So attempting to do a synthesis of this input that was received so far, one of the themes that stood out, at least to me when reading all of these, is that there's several of the commissioning notes have this focus on data sets that could be used as a reference for characterizing the LSST wide fast deep performance. And so in many cases, they recommend very deep observations, 10-year or even 20-year equivalent depth exposure, so very high signal to noise. They would like high cadence in a very dense temporal sampling over at least a few hours and ideally over a few consecutive nights. This is actually, you would achieve the depth at the same time you achieve this temporal sampling if you do the observations right. And again, this would be used as basically for classification of transient and variable objects. And then ideally they would like this to be multi-band and basically as many bands as possible so that you can do, basically it can be used for a broader range of science, and you can also do all the photometric redshift and SED fitting and so forth. So when you look at these recommendations, it turns out that many of them can be met with a series of 20-year depth pointings. So this would be more than 1,000 visits across multiple bands in a span of few nights. This achieves both the depth and the temporal sampling. This data set could have a very high legacy value, in part because it's distinct from the nominal LSST wide fast deep survey, and could potentially serve as a truth catalog for LSST that would have significant value as sort of a way of calibrating the main survey for several years to come. at least as some of the suggested target fields for these types of observations. The DDFs were mentioned multiple times. The Solar System Science Collaboration had some specific recommendations for the outer solar system, including the OSOS and deep fields. And then there was also interest in observing some moderately dense stellar fields where you don't have too much PSF overlap and you have low interstellar dust extinction, but where you have a very large number of stars that you could use for investigating various systematics, as well as for being able to study variable stars if you have this high temporal cadence sampling. So here's just some snapshots from the commissioning notes showing some of the proposed target fields in tabular form. But what might be more useful is seeing how these are arranged on the sky. So again, these are just selections from some of the commissioning notes. One thing that was good to see is that many of these suggested fields, they're spanning a pretty wide range of right ascension and declination, which means that across the commissioning notes, we have recommendations that would be observable in all different times of year, which gives us some flexibility depending on exactly when these surveys take place. Finally, I want to mention some of the proposed specialized observing programs. These were programs that don't necessarily fit into the normal testing of LSST survey itself, but which could be quite interesting in terms of stress testing the observatory and its capability to conduct particular observing modes. So some of these specialized observing programs were observations of active comets. And again, the specific targets would have to be discussed with the Solar System Science Collaboration closer to the time of on-sky observations with commissioning. Multiple science collaborations mention this concept of twilight observations, including low solar elongation and high air mass. These would be, again, looking at near sun comets, interior Earth NEOs, but also more generally assessing the camera performance in twilight and thinking about this as a pilot for twilight surveys that could be conducted with LSST. There's a very interesting idea where if we need to take an observation of a very bright target to basically choose one of the giant planets, for example, Uranus or Neptune, as the target, so that you could study the detection of faint sources near very bright saturating sources and study the effects of scattered light, the glare structure, your ability to model and subtract this very bright light from a nearby target. And then again, mentioning the short exposure survey that was mentioned in a few different commissioning notes. Okay, so let me pause here for questions again, now that we've done a review of the input received to date.
Keith, there was a quick question that got some comments in the chat, but maybe you could also chime in on it, which was if anybody had asked for DCR verification as part of their requests. Yes, that did come up. So I didn't list it on this slide, but the Milky Way Stars Local Volume Collaboration did specifically mention DCR. And I imagine that this would be of interest to the desk as well. So that did come up.
And then Mario has his hand up.
Yeah, thanks, Keith. My question is, if you did the 20-year survey in commissioning, would that preclude testing of just the regular wide fast deep mode while you're commissioning?
Keith, do you want me to take that one?
Sure, you go ahead, Chuck.
Yeah, so Mario, the current plan that we have for the final science verification validation surveys as you know, it's split into two pieces, right? There's a science verification number one, or science verification survey number one, is aimed at doing some of the things that we were just talking about, validating the DCR corrections, and also being able to produce templates for alert production. And that would be operated in a deep, wide, fast mode, right? So it is meant to be a wide area survey over a wide range of parameters. And then interspersed with that will be the, the 20-year or 10 or 20-year concentrated small field of, small relative area of sky taken to, extreme depth. So yes, we will exercise deep, wide, fast. We will likely exercise that well in advance to the science verification surveys during both with ComCam and LSST-CAM, mostly as a technical verification that the scheduler is working as we expect it to work. Does that answer your question?
And if you switch to this, other option that Keith showed, like 100-degree, 20-year depth survey, does all that still stand?
Yes. Like I said, the two science verification surveys, one is meant for demonstrating deep, wide, fast and alert production over a wide area, and the second is designed to take a limited number of fields to extreme depth. And both of those surveys will be scheduler driven, given the feature properties of our current schedulers allows for that to be done.
All right. Okay. So this second slide that Keith showed, that just replaces the wide area survey, the 800 square degree survey with a 100 square degree but deeper survey, but everything else remains.
Yeah, and I think what Keith can comment, but I think what Keith is showing is that get within the boundary conditions that we have at the end of the project for the science verification surveys, we have many different options that we can take, and we have a straw person construct for how we would use that time, divided between wide, fast, deep, like observations that would enable verification of the template generation and the alert production, and then taking a limited area down to 20 years worth of depth.
Sounds good. Thanks. I have a number of other questions, but I'll yield back, and then if nobody else wants to ask one, I might come back.
Okay, real quick, we do have another one. I believe this would be for Chuck. Has the commissioning plan been converted into a real schedule? If so, how much time contingency?
Let's see. Let me see. Yes, the commissioning plan carries risks on the project overall, generally, and the project-wide contingency allocation for schedule is right now 6 months. And that folds in, that 6 months is derived from contingencies across the project. It's not just commissioning. But I will say a good chunk of it is being driven by commissioning. But I will also say that in the planning for commissioning, we have built into our time estimates and our technical estimates contingencies for weather, depending on which season we're actually doing on-sky observations. And we also factor in on the commissioning plan the discovery of the unknown unknowns, right? Is that, that's what commissioning is all about. is that we are going to discover things that we did not plan for, and that need to be solved. And so we do have time. So the current commissioning schedule and plan has margin in it to accommodate those kinds of discoveries. And then on top of that, we have the overall project schedule contingency of 6 months. I hope that answers the question.
Thank you, Chuck. As of right now, there's not any other questions in chat.
I see a raised hand from Rick Kessler.
Yeah, I had a follow-up to the contingency question. From past experience, commissioning, usually goes really well, but there are also typically significant problems that remain. One of the advantages of past surveys is we had off seasons. They were not year-round. And we had these off seasons to fully focus on fixing these problems. But there is no off season for LSST. And if everyone is fully transitioned to just running the survey, who's going to fix these remaining problems? How is that going to happen? Is there a plan for that?
So let me address that in multiple versions of the answer. So number one is when we transition to operations, the technical team that built this system essentially remains intact. So it's not like the technical team, goes off and does something completely different. So particularly for the observatory operations in Chile, the team in Chile, they're not going away. They will be part of the operations team, and that is also true across most of the rest of the project. So that's part of the answer. The expertise will still lie within the operations effort to make these kinds of improvements, and we all acknowledge. So one of the deliverables from the construction project to the operations team is a comprehensive report on improvements that should be made on various timescales. And all I can tell you right now is that within the operations planning, there is conversations going on about, a planned pause, if you will, in the survey operations to address some of these technical improvements and technical corrections that need to be made. So I want to be sure with the audience that we have, looking at my screen, we've got 141 people here, that there is a plan, there is a maintenance and improvement plan within operations where we will constantly be upgrading and improving on the system performance. And there will be times that we, in the overall operations plan, we do have planned shutdown times that is baked into the schedule. And those times will be used to do things like recoat the mirrors, make technical improvements, etc. So it's not like, I just want to make sure that people understand that it's not like when we flip the on switch that we just go for 10 years with doing nothing. That's just not even a reasonable way to go about things. Because the system's going to have to be maintained, it's going to have to be improved, and I just want to make sure that you understand that that is part of the operations plan. I will conclude with my long-winded answer that we also have in the commissioning period, we have planned segments in our schedule that I use the term engineering punch list resolution time. So that's baked into our schedule. So we know that we're going to accumulate issues as we go through the commissioning period, and we need to dedicate time to address those issues. And that is baked into the schedule as well. So I'll leave it at that. I'll hope that answers your question.
And then Mario's hand is raised.
So another question, I don't know what is for Chuck or Keith, but what's the earliest you expect we'll be able to test processes that have to run in real time? So I'm thinking things like incremental template generation or prompt processing pipelines, or for the solar system, for example, we have nightly exchange of data with the Minor Planet Center. What's your feel whether some of that is going to be able to be done with ComCam, or does it wait for LSST-CAM or even SV?
That's
I'll
a good question.
actually, I was going to defer this to Leanne or Robert, maybe.
Well, I think we can do it with Auxtel, and I'm hoping to get the first prototype running sometime next year, is the answer. Whether we'll go as far as solar system, I don't know, but take data and turn it around on a short time scale. I don't think anybody will be interested in the answers. You can image about a square degree an hour to a not very deep depth of 1.2 meter, but it stresses a lot of the infrastructure sorts of things. So it should be ready to go by the time we got ComCam on the sky.
I could just add to that, Mario, we are planning to release alerts, canned alerts for DP1, that's ComCam data. So we should certainly be running template generation by that stage, incremental or otherwise. Incremental template generation basically is just running the template generation pipeline outside of DRP on probably a number of images to generate the template.
So Leanne, Chuck here, if I could interpret a little bit what Mario was asking, is I think he was asking more about the timescale, about how these would be produced. Because I think right now, during both ComCam and LSST-CAM, we're not planning on doing template generation and alert production in real time.
Okay, if that's what you're asking, sorry, Mario.
That's kind of what I'm curious about. When do we have sort of verification that this thing will work, where we run it 24 or 48 hours, all the pipelines, and kind of see where there are still things we need to fix.
Yeah.
So
okay.
I addressed part of that, Mario. I addressed when we would have the plumbing in place. That doesn't address the when. And then Leanne will tell you more of the answer.
Yeah, if you come along to the early science session next, Mario, we are going to discuss that, and I'm very open to receiving community input on this. I'll say at the moment, what we're planning is to be able to produce canned alerts that is not in real time, but to be able to run the pipelines and produce alerts and allow the brokers to have access to them, not on the 60-second timescale. It'll be a much longer timescale than the 60 seconds for DP1, but for DP2, which is essentially readiness for going on Sky, we will be producing live brokered alerts. So that's when we have to test that the live brokered alerts will be working so that we can start operations. So that's part of the science verification survey with LSST-CAM.
So right now the plan is to do that kind of full-blown system around SV basically.
Yeah. I mean, I think our verification has to also, basically the community brokers are third-party brokers, as you know, so they will commission themselves, but obviously they have to work with us and we have to work with them so they can commission it. So
yeah, no, I'm more worried about things. Sorry, go ahead.
No, just to finish, we're expecting to provide a live alert stream to them as part of the science verification surveys and data preview too.
Yeah, that sounds great. I'm just curious about when do we have a chance to try to run everything we're supposed to run on a daily basis for the first time, and because usually when you put a lot of different systems together, even if they work well all by themselves, you put them together and then you discover all these things that you didn't plan for. So I'm just curious when that happens for us, and it sounds like it's in science verification, so we'll have about 2 to 4 months to fix any issues that arise. All right, thanks. That answers it.
Okay, and then we do have another question. Do we know anything about phase angle coverage for asteroids? Will we be able to observe them during opposition?
So let me ask a question of the question. Is this a question about observing during commissioning, or is this a question about observing during operation?
That's a good question.
might
Miley
wanna
is the one
come-
that did it.
You might want to come back to this one or answer it offline, just since we have a few minutes left now.
So let me just quickly respond to that, is that aside from the science verification surveys at the end, the observations during the ComCam integration period and the LSST-CAM integration period will be driven and prioritized by our technical needs, and we will fit in where possible scientific observations as a sort of with an opportunity. So I would say during the early phases of commissioning, no, there's going to be, I hate to say this, but there's going to be no real effort to observe phase angles of asteroids during that time period. We're going to get what we get, basically.
Okay, so yeah, so I'd like to move on since we have about three minutes left. So just to touch on the next steps. So this slide that I'm showing now has the roadmap to this detailed observing strategy. Right now, we're at the stage where we have a nominal plan and we have the input received from the community, but we haven't yet done the mapping into detailed observing scripts that could actually be executed. On the technical side, the project is now beginning to exercise the technical capability to conduct scripted on-sky observations. This is starting with Oxtel now. And what we're also doing on the project side is developing detailed science verification test plans, where we will basically have the step-by-step procedures for how we're going to do these tests and what pipelines need to be run and the algorithms that will be run for the testing. And so we're going to use that to drive the overall design of the on-sky observing programs during commissioning. And we will be sharing more information as that observing strategy is being developed. We'll show more of that information with the community. And we will also be in touch with operations and the survey cadence optimization committee to understand any LSST considerations that come into play. So in terms of the timeline, we will be assembling the menu of candidate target fields roughly 3 to 6 months before the start of on-sky observations with ComCam, and we'll be using the community input and creating that menu. We plan to publicly release this menu, but that should not be interpreted as a commitment to observe any particular target. It's simply a statement about the candidate fields that we are considering and that we are prepared to observe. And then also during this phase 2 of community interactions around commissioning, we'll, as needed, reach out to points of contact from the commissioning notes and commissioning liaisons to discuss the details of the observing strategy, potentially including external reference data sets. And then finally, a few weeks before the planned observations with LSST-CAM and ComCam, we'll actually do this mapping into the specific observing programs. And then finally, just to close up the session, we'll say, again, thank you very much to the commissioning liaisons who helped coordinate this previous effort. The commissioning liaisons will continue to be valued points of contact between the science collaborations and the commissioning team, SITCOM. And I think it's important to say that there's a distinct and complementary emphasis between the participants in this commissioning announcement of opportunity, in the sense that those participants are not representing particular science collaborations in the AO, whereas these commissioning liaisons can be more spokespersons for their science collaborations in terms of interfacing with commissioning. For the time being, we will continue to welcome updates to the commissioning notes. There was because of the delays in the past year, many of which were beyond our control, we were expecting that we would need this information sooner. Now the start of on-sky observations has been pushed back. And so if there are any updates, we would welcome those through at least the end of this calendar year. You can continue to discuss with the commissioning liaisons or LSST community. And then finally, I'll just mention again, this commissioning announcement of opportunity. This is a distinct pathway for interacting with the commissioning team. If you're interested in that, we would certainly encourage you to check out the information from the session yesterday, or reach out to Chuck and I if you have more questions. So I'll stop there. Any final questions or points to raise before we close up the session?
And no more on chat right now.
All right. Thank you again, everyone, for your input on this process. It's been extremely helpful to us in our planning, and we will be, we'll continue to be in contact.